This section introduces a GitHub Actions workflow aimed at automating the deployment of a private repository to a VPS. The previous deployment folder is renamed to keep a historical record. Here, the motivation for the project is articulated. Users with private repositories on GitHub can streamline their deployment process to a VPS whenever changes are pushed to the main branch. This section is dedicated to the installation process of the project. Details are provided on the necessary workflow file, clone repo on vps.yml. Users should copy this to their repository's workflow directory and modify parameters, such as the VPS IP, according to their project needs. This part explains the single setup of the VPS CICD private key secret in GitHub repository settings, necessary for connecting to the VPS. A visual guide is suggested, illustrating the location of secrets on the GitHub dashboard. Continuing from the previous viewport, this section describes the procedure for creating a new repository secret by entering the private key for the VPS user. Another image illustrates this process. This section outlines the technologies utilized in the project, including SSH for secure connections, public-private key authentication for access control, and the GitHub token for repository interaction. Additionally, it briefly mentions the ACT tool and the hosting environment as a DigitalOcean droplet. In this section, the usage of the project is summarized. Users need only push changes to the main branch of their repository to trigger the deployment process. The high-level design outlines 4 essential components involved in the deployment process: the Git push action, GitHub hosting the private repo, the GitHub Actions runner executing the workflow, and the VPS, where the repo is deployed. An accompanying diagram aids in visualizing the interactions among these components. The visual representation accompanying the previous summary illustrates the flow and interaction among the 4 components of the deployment related to the repository. The design section presents questions raised during the creation of the repository, hinting toward a thoughtful approach in addressing challenges in private repo access and deployment procedures. This question addresses the challenge of accessing a private repository. The solution involves utilizing the GitHub token, which provides authenticated access when cloning the repo. This query discusses how the VPS retrieves the private repository. The process involves the GitHub runner copying the GitHub token to the VPS, which then allows it to perform a git clone operation. Here, the question revolves around securely storing the VPS SSH private key for the runner to access it. The recommended solution is to use GitHub secrets for secure storage, ensuring that sensitive data is protected. The code structure section will showcase the actual implementation of the workflow file used for deployment, specifically highlighting the clone repo on vps.yml. This setup section outlines the initial configuration for the GitHub Actions workflow, defining job variables such as the VPS user, IP address, GitHub token file location, and deployment directory, ensuring organized and secure deployment references. Step 1 involves securely configuring the GitHub repository's token to be used in subsequent steps for authenticated interaction with the repository. In Step 2, the environment is prepared by creating an SSH directory and storing the VPS's private key in a specified file. This includes setting file permissions to ensure security by using chmod 600. Step 3 assigns the GitHub token, retrieved from a secure location, to a predefined file for use in git clone commands, facilitating interaction with the private repository. In Step 4, conditional logic checks if the deployment directory already exists. If it does, it renames the current directory by appending a timestamp, thus preserving old deployments before the new clone occurs. Step 5 executes the clone operation, where the deployed application is cloned into the specified directory on the VPS using the constructed GitHub URL, utilizing the GitHub token for authentication. Step 6 concludes the workflow by removing the GitHub token file from the VPS, ensuring that sensitive information does not remain on the server after deployment. In the demo section, users are encouraged to monitor the status of their deployment on the GitHub dashboard after pushing to the main branch, as illustrated in the accompanying image depicting a successful deployment. This part emphasizes the importance of keeping the VPS IP address in GitHub Actions secrets for security, while also discussing the functionality of the ACT tool, which allows for specific job invocation during testing. The Possible Improvements section suggests enhancing security by avoiding exposure of the GitHub token on the VPS through direct file copying methods. It also recommends incorporating project-specific tasks into the workflow for a more tailored deployment experience. This section highlights open issues, such as the generic naming of the private key, which may lead to compatibility issues, and mentions a specific image depicting failure to complete the workflow that could provide insights into any lingering problems. Finally, the References section provides a list of resources, including videos that cover SSH essentials, GitHub Actions, and tools that enhance local workflow management, serving as additional learning material.